Hello, I'm Dr. Ian McCullough, and I'm going to prove one of my favorite statistical paradoxes, Murphy's Law. So Murphy's Law basically states that, that if something bad can happen, it will, right? That's Murphy's Law. But if I were to treat this statistically, right, Murphy's Law, right, I would write it like this. So statistically, I would write it as given some number of mutually independent events, A1, A2, all the way up to AN, then the probability that none of them will occur, probability that t equals 0, is less than or equal to this exponential function raised to the negative expected value of t. Okay? So what that's saying is, given that there's a whole bunch of events and the likelihood of any of those happening might be low, the likelihood that at least one of them, right, that is going to happen is actually maybe possibly high. Let's look at this. I'm going to first give you the proof, because I did tell you I was going to prove Murphy's Law. So the proof is probability t equals 0. So the probability t is going to be, that none of these events occur, is actually going to be the probability. And I'm going to use this notation. So there's the probability that event 1 would happen. So I'm going to use this notation here to say the complement, right? This is the probability it would not occur, right? So that's the probability of A1 not happening and the probability A2 not happening, and all the way up until I have the probability AN does not happen. And so what that is going to equal is it's going to be the product from 1 to n of the probability of none of these events, the ith event, not happening. Well, that is the same thing as saying the product here, I equals 1 to n, of 1 minus the probability that the event does happen, right? So the likelihood it doesn't, right? Again, look at my shirt. Something happened, right? So the likelihood of something happening there, so if we subtract the probability that the event did occur, that gives us the probability that the event does not occur. Okay? So for all x, we have 1 minus x is going to be less than or equal to e to the negative x, right? That's what our claim is here. So I can say that this is less than or equal to the product I equals 1 to n, e raised to the negative probability that the event occurs. And so that equals e raised to the sum of 1 to n times the probability that the event occurs, which is then e to the negative expected value of t. Okay? Negative expected value of t. And so that becomes the proof for Murphy's Law, that this equation is true. There's a corollary. So corollary, if we look at this, right, if we expect 10 or more mutually independent events to occur, the probability of no event occurring is less than e to the negative 10th, which is about 1 over 22,000. So it's interesting to note that this doesn't depend on n. Right? It doesn't depend on n. And so this explains coincidences or miracle. Right? So what we'll observe is we'll observe some event happening. like a man struck by lightning, right? And it's a miracle, right? It's it's amazing that this guy's happening because the likelihood of you getting struck by lightning is so low. But given the millions of people on Earth, right, the likelihood that nobody is ever struck by lightning is then also low. Maybe a more practical example is, let's say you're in a company and you're bidding on proposals. And so the probability of you winning the proposal on a set of proposals is low. So you might have, let's say, 10 proposals that you have submitted, right? 10 proposals, maybe they're all kind of similar, maybe they're not, but you've submitted 10 proposals to different clients, and the win probability of each of those is actually pretty small. Well, according to this, the likelihood that none of those are going to win is then also low, extremely low, and so maybe you want to start hiring staff to be able to meet the demand that you're going to have on one of those contracts, right? That's kind of an approach for diversification. So that's partially why we like to diversify things. So if I see that I'm submitting bids to a larger variety of tasks or programs, right, then I may want to hire ahead of demand and staff some of those projects because the likelihood that I will have no work for these people is done. And if they're rare events, if they're truly rare, then I can also apply Markov's law theorem to begin to estimate roughly, where should I, based on some risk tolerance, where should I start hiring ahead of demand to be able to meet whatever contracts I might win or might deliver.